What's up guys, this is Engineer Jack and this is Reinforced Concrete. So yung topic natin for this presentation is about the types of failures and strain limits. Number 2, the strength reduction factors. Number 3, the balance condition. Number 4, the beta 1. Number 5, the balance steel reinforcement ratio. Number 6, the upper and lower steel percentages. And number 7, the spacing limits and concrete protection for reinforcement. So, unahin ko muna guys yung types of failure and strain limits. There are 3 types of flexural failure of structural member, and this can be expected depending on the percentage of steel used in the section. So number 1, steel may reach its yield strength before the concrete reaches the maximum strength. In this case, the failure is due to the yielding of steel reaching a high strain equal or greater than 0.005. The section contains a relatively small amount of steel and it is called tension-controlled section. So, this is the behavior niya. So, for this failure, mauna mag-fail yung bakal natin kasi kaunti lang yung amount of steel na ginamit natin before mag-fail yung concrete natin. So, yung easy natin is less than yung maximum strain of our concrete which is 0.003. So, ganito yun. So, yung easy prime, ito yung 0.003 na yung maximum strain of our concrete na pag na-reach na yun, mag-fail yung concrete natin in compression. Pero, for this section nga, na-reach natin yung yield strength of our concrete which is the Fy. So, yung Fs natin or yung actual na dinadala ng steel natin is yung Fy na kasi nga naabot niya. Ibig sabihin, yung strain natin equal to strain S or pag na-greater than or equal to 0.005 na strain, automatic this is tension controlled. Ibig sabihin, mag-fail yung beam natin due to yielding. And the ACI code assumes that the concrete fails in compression when the concrete strain nga reaches 0.003. For this slide, yung ginamit ko is EC prime, pero i-indicate ko naman mamaya if EC equals to 0.003, that is the maximum strain in our concrete. Number 2, if the steel may reach its yield strength and at the same time, the concrete reaches its ultimate strength, the section is called balance section. Ibig sabihin, kung nag-yield yung bakal at the same time naabot natin yung 0.003 na maximum strain of our concrete, ibig sabihin, this is a balance condition. So, ganun nga. So, naabot natin yung 0.003 and this is a strain diagram. Tapos, this is our stress diagram. And for number 3 naman, when the concrete may fail before the yield of steel due to the presence of high percentage of steel in the section, in this case, the concrete strength and its maximum strain of 0.003 are reached, but the steel stress is less than the yield strength, or that is Fs, kasi yung Fs, this is our designation for actual stress in our steel. And if it is less than Fy, ibig sabihin, hindi pa nag-yield yung natin yung bakal. The strain in the steel is equal to or less than 0.002. This section is called compression control section. So, ito yung drawing niya. So, this is the strain diagram ulit. So, yung actual strain natin dito is less than or equal to the yield strain or itong EY. That is also equal to Fy over the modulus of elasticity for steel or ES. So, syempre dito, pag nag-less than yung actual strain natin, mag-less than yung actual stress din natin sa yield stress natin. So, natawag dito, pag nauna mag-fail yung concrete natin or for our compression fiber, or naabot yung 0.003 na strain for our concrete, this is called a compression controlled section. And tandaan, for tension controlled, pag yung strain natin na greater than or equal to 0.005, automatic that is tension controlled. Pero for this compression controlled section naman, pag na-check natin yung strain in our steel, if it is less than 0.002, automatic that is compression controlled section. So in beams designed as tension-controlled sections, steel yields before the crushing of concrete. The cracks widen extensively, giving a warning before the concrete crashes and the structure collapses. So for example, ito yung figure niya. This is a tension-controlled section. Kung sakali man mag-fail yung beam natin na dinesign natin, at least dapat yung failure niya is tension-controlled section. Kasi nga, in tension-controlled section, nagbibigay siya ng warning kasi nagkakaroon tayo ng cracks sa bottom of our concrete. Pero pag yung balance ang nangyari or compression-controlled section, if this failure occur, dahil sa sobrang dami na ginamit natin ng bakal, hindi siya mag-yield, ibig sabihin, mauna mag-fail yung concrete natin. So, ganito yung yung mangyayari. Kaya yung tension control yung ina-adapt ng ACI or our NCP. So ito yung ina-adapt natin in designing of beams. So in beams designed as balance or compression controlled sections naman, the concrete fails suddenly and the beam collapses immediately without warning. So the ACI code does not allow this type of design. Even our code na NCP, adapted lang naman nila yung ACI. So in designing of beam, kung sakali man mag-fail yung beam natin, at least dapat tension controlled section sila, hindi compression controlled or balance. So the ACI code in section 10.3 defines the concept of tension or compression controlled sections in terms of net tensile strain, or yung symbol natin is yung ET. This is the net tensile strain in the reinforcement closest to the tension phase. So kanina yung mga ginagamit ko is strain S or yung actual strain na sinasabi ko kanina. Pero ngayon gagamit tayo ng net tensile strain, pero yung kukunin natin ng net tensile strain is yung pinaka-close sa tension phase, or ibig sabihin yung pinaka-lower part of our steel reinforcement. So moreover, the two other conditions may develop. So balance strain condition, and pang-apat, we have also the transition region condition. So bali meron tayong apat na section. So we have the tension controlled, compression controlled, the balance condition, and the transition region condition. So these four conditions are defined as follows. So for compression, these are those sections in which the net tensile strain or ET at nominal strength is equal or less than the compression controlled strain limit. So yung strain limit natin is equal to 0.002 nga. So pag less than dyan, automatic makukuha natin is compression controlled section. Or that is also for 400 megapascal, kasi nga yung 400 megapascal pag kinuha natin yung strain nito 400 all over 200,000 megapascals. Kasi yung 200,000 megapascal, that is the modulus of elasticity. So, para nga makuha natin yung yield strain, so Fy divide Es, or yung modulus of elasticity nga, so that is 0.002. At the time when concrete in compression reaches its assumed strain limit of 0.002, so before maabot nga yung 0.002 for steel, tapos naabot naman yung 0.003 for concrete, automatic that is compression control. So this case occurs mainly in columns subjected to actual forces and moments. So pag magde-design kasi tayo ng beams, dapat nga tension control para magbibigay siya ng warning, pero yung compression control usually ginagamit to or sa pag-design ng columns. So ito yung behavior niya in our beams, yun nga na yung strain natin in our lowest part, kasi yung kukunin natin dito, if we have two or more layers, meron tayong effective depth, the D, and meron tayong DT. So yung DT, ito yung location of the centroid na yung lowest part, yung pinaka-closest na steel in our tension phase. So doon natin kukunin yung DT, another designation yan. So dito din natin makukuha yung ET natin or net tensile strain. So yung net tensile strain nga, dito natin makukuha. Kapag naabot niya yung 0.002 or less than, automatic that is compression controlled. Yun nga, at the same time, naabot yung 0.003 for our concrete. So next, yung tension control nga. So these are those sections in which the net tensile strain is equal or greater than 0.005, just as the concrete in the compression reaches its assumed strain limit of 0.003. So basta pag naabot natin automatic yung 0.005 na at the same time naabot yung 0.003 in our concrete, that is tension controlled sections. Number 3, in sections naman in which the net tensile strain lies between the compression controlled strain limit na 0.002, that is for Fy 400 megapascal, and the tension controlled strain limit of 0.005 constitute the transition region. So, yung range of our net tensile strain dito, so yung kukunin natin nga yung pinaka-lowest part of our steel. So, pag yung range niya is from Fy over Es to 0.005, ibig sabihin nasa transition region tayo. And for number 4, this is the last part of our condition na yung balance strain condition nga is developed in the section when the tensile steel with the first yield reaches a strain corresponding to its yield strength, or yung Es nga natin or ET. Basta pag mayroon tayong 2 or more layers, kung gamitin natin is yung ET or net tensile strain. Pero kung isa lang naman, okay lang naman yung gamitin natin na variable na strain S or the actual strain. If that is equal to Fy over Es, tapos naabot natin nga yung maximum strain in our concrete at the extreme compression fibers reaches 0.003, that is balance condition. So ito yung drawing niya. Pag naabot natin to, at the same time ito, that is balance strain condition. Tandaan nyo lang guys yung mga ginagamit ko ng mga variables. Basta pag mayroon tayong 2 or more layers, tapos i-check natin kung anong condition siya. So dapat kukunin natin yung dt, then dyan na natin makukuha yung net tensile strain. Tapos i-check natin if that is equal to Fy over Es. That is balance condition, and at the same time naabot yung 0.003. So for section 10.3.5 of the ACA code indicates that the net tensile strain, or this 80 at nominal strength within the transition region shall not be less than 0.004 for reinforced concrete flexural members without or with an axial load less than 0.01 FC prime AG, where AG is the gross area of the concrete section. Pag na-solve natin guys yung strain natin na nasa transition region siya, it shall not be less than 0.004 para ma-design nga natin yung flexural members natin or beams. So yan yung limit natin pag nasa transition region. At least dapat kasi yung beam natin na de-design natin at tension controlled section. Pero kung naabot niya yung transition region, yung limit natin at least 0.04. So wala tayong gagawin kundi i-adapt lang yan kasi galing yan sa code natin. So kung ipapakita ko lang guys yung apat natin na condition, ito yung yung figures nila. So tatanda lang natin itong mga values. So for compression control section, yung strain natin dito is less than or equal to 0.002. Yung sa concrete natin lahat naabot yung 0.003. Pero pag yung range natin is from 0.002 or Fy over Es to 0.005, nasa transition region tayo. If our strain is greater than or equal to 0.005, that is tension control section. So at least ito dapat yung failure niya, kung magbo-fail man yung beam natin, yung design of our beam, at least dapat nasa tension control siya or nasa transition region na yung strain natin at least 0.004. Tapos for balance naman, hindi natin ito ginagamit in designing of our beams. Kung sakali man mag-fail yung beam natin, hindi dapat siya balance strain or compression control section. So next, pag-usapan naman natin yung strength reduction factors or yung symbol natin is phi. So these factors or phi for under strength are called strength reduction factors according to ACI 9.3 and are as follows. So we have strength condition and we have the factors. So for flexure, in designing for our beams, so meron lang tayong tension controlled sections. Yung value of our phi, that is 0.9. And for compression controlled sections naman, we have spirally reinforced. Na yung value of our phi is 0.75. And for others, or for example, meron tayong rectangular or square na dimension, yung gagamitin natin na phi is 0.65. So, and for shear and torsion naman, yung phi natin na ginagamit is 0.75. So, dapat sa ulo natin yan kasi hindi yan given guys sa board. So, number 3, in bearing on concrete, yung phi natin is 0.65. For number 4, post-tension anchorage zones, yung factor natin or phi, that is 0.85 naman. And for struts, ties, nodal zones, and bearings areas in strut and tie models, yung phi natin is 0.75. So, ito guys na mga phi, ginagamit natin yan in our nominal moment capacity. So, minumultiply natin yan doon sa strength natin or sa nominal moment strength, even sa PN, sa VN. Kasi yung purpose ng P, meron tayong inaccuracies of our FC prime and FY. Kasi yung FC prime natin and FY, ginawa natin yan, man-made yan. Ibig sabihin, pwedeng hindi yan perfect na yung value niya. For example, yung FC prime natin, that is 30 megapascal. And for FY, that is 400 megapascal. Kasi yung FC prime natin nakakuha yan depende sa pagkahalo, and yung FY depende din sa pagkakagawa ng manufacturer. Ina-assume ng code na hindi nga siya perfect, so nagmumultiply tayo ng strength reduction factors. And at the same time, yung sa MU natin, ito yung nasasolve natin due to our loads, and nagmumultiply tayo ng load factors. So kahit binawasan natin yung nominal moment strength natin ng strength reduction factor, it should be greater than or equal to our MU, which is galing nga sa loads natin na mayroong load factors or minagnify na loads. And nakidikit din naman kasi yan sa code natin, and galing to sa NCP 2015. So for section 422.1.3, the design strength, kasi yung design strength, ito na yun, na strength reduction factor times MN, and at the section shall be taken as the nominal strength multiplied by the applicable strength reduction factor phi, and is given in section 421. So for our transition region, so as you can see in the figure, ito yung range natin pag kung nagko-consider tayo ng transition region para ma-solve natin yung value of phi. So for spiral members, ito yung formula niya, that is equal to 0.75 plus closing parenthesis na is net tensile strain minus 0.002 closing parenthesis times 50. But for other members, for example, meron tayong rectangular or square, yung phi natin, that is 0.65 plus closing parenthesis net tensile strain minus 0.002 times 250 over T. So, dapat sa ulo nyo yan kasi hindi natin makukuha yung design strength of our beam kung hindi natin sa ulo yung mga strength reduction factor. Especially kung nasa transition zone tayo. So, pag-usapan naman natin guys yung balance condition. So, this implies that the ultimate load strain in concrete equals to 0.003 and at the same time naabot natin yung strain na Fy over Es or the yield strain at distance dt. So, for example, meron tayong beam na meron tayong 3 bars. And this is the width, this effective depth. So, if we have single layer na steel reinforcement, automatic yung effective depth natin that is also equal to dt. So, yung strain diagram nga, naabot natin yung 0.003 and yung yield strain. And this is our stress diagram. This is the equivalent rectangular compressive block na mayroong depth A. And yung thickness niya is 0.85 fc prime para maging rectangular kasi from parabolic siya to rectangular. So, ginawa natin na 85%. So, yung volume niyan, that is also equal to the equivalent compressive force na 0.85 fc prime AB. And for tension naman, ito yung dinadala ng steel reinforcement na that is equal to AS times Fy. So, kung balance yung gagamitin natin, dapat yung mga variables din natin dito for A and for AS dapat gagamitin din natin is for balance. So, by ratio proportion, kung titingnan natin itong strain diagram, so we can say that the base over itong height, CB over 0.003 is equal to D or itong D, ito yung pinaka-total ng height ng triangle. Tapos, yung base niya is yung sum of 0.003 and yung Fy over the modulus of elasticity. So, simplify natin. Cross-multiply. So, magkakaroon tayo ng 0.003 D all over 0.003 times plus Fy over Es. Then, substitute the value of Es or that is equal to 200 gigapascal or 200,000 megapascal. So, that is 0.003 D all over 0.003 plus Fy over 200,000. So, simplify natin, itong denominator, equivalent din yan sa 600 plus Fy over 200,000. And itong denominator, pwede pa natin iangat yung 200,000. So, mag-multiply tayo sa numerator. So, magkakaroon tayo now na 600D all over 600 plus Fy and that is equal to the C balance. So, yung C balance nga, for balance condition, ito yung location of our neutral axis from the top fiber. So, kailangan natin ito isaulo na formula. Let's say, mag-summation of forces horizontal tayo equal to 0. So, automatic, yung T equals to C. So, for T, that is ASFY, and yung for C, that is 0.85 FC prime AB. So, yung A, this is the depth of the compression block. And yung formula natin for A, that is also equal to the beta 1 C. So, ito yung bago natin sa formula. So, dagdag naman yan, nakalagay yan sa code. So, for our balance condition, syempre, gagamit din tayo ng A balance and C balance. So, yung A balance natin, that is also equal to beta 1 times C balance. Another formula na kailangan natin isaulo. So, sa NCP guys, meron tayong value for beta 1. So, for NCP 2015 or the latest NCP, so yung equivalent natin for beta 1, meron tayong condition na nakadepende tayo sa FC prime. So, if our range of our FC prime is from 17 megapascal to 28 megapascal, automatic yung beta 1 natin na gagamitin is 0.85. Pero yung range naman niya is greater than 28 megapascal to less than 55 megapascal, yung gagamitin natin na formula for beta 1 is 0.85. Dapat dito guys may minus, this typo lang. So, 0.85 minus 0.05 times FC prime minus 28 all over 7. That may minus sign dyan. So, typo lang yan. And for FC prime naman na greater than or equal to 55 megapascal, yung gagamitin natin na beta is 0.65. Pero kung sa mga naunang NSCP edition guys, so sa NSCP 2010, the factor beta 1 shall be taken as 0.85 for concrete, strength FC prime for 17 megapascal, so automatic 0.85 to 28 megapascal. So pareho sila dito sa condition na letter A. And for strengths above 28 megapascal, beta 1 shall be reduced linearly at a rate of 0.05 for each 7 megapascal of strength in excess of 28 megapascal. But beta 1 shall not be taken less than 0.65. So, itong condition pareho dito sa letter B na condition. So, 0.85 din minus 0.05 FC prime minus 28 all over 7. So, same lang sila. Ang kaibahan nila, wala siyang limit. Basta greater than 28 megapascal. Pero for our NCP 2015, nag-limit siya pa greater than 55 megapascal, automatic 0.65. And for NCP 2001 naman, or 1992, kasi ito yung mga edition natin ng mga NCP codes, yung beta 1 natin is 0.85 minus 0.008 times FC prime minus 30 megapascal. So, ito naman yung condition natin if FC prime na greater than 30 megapascal. But if FC prime natin is less than 30, automatic 0.85 din yung gagamitin. Pero syempre, yung i-adapt natin is the NSCP 2015. So, meron tayong dagdag formulas. So, for C balance and for our value of A and for our value of beta. So, next, meron din tayong the reinforcement ratio for tension steel na yung rho natin, ito yung term natin for the ratio that is equal to AS over BD. So, kung mapansin nyo, hindi BH yung ginamit natin or the area of our beam. Yung ginagamit natin is the effective depth. So, AS over BD. So, for balance reinforcement ratio, syempre, yung gagamitin natin is phi balance. And for our area of the steel, dapat nakabalance din. So, AS balance all over BD din. And that is also equal to, if we equate C and T, or itong C na bigger C and T, makukuha natin na 0.85 FC prime AB equals to AS FY. So, ang gagamitin natin is balance condition. Ibig sabihin, yung gagamitin natin na AS is AS balance din, and for A natin, nakabalance din. So, yung AS balance natin is equal to 0.85 FC prime A balance times B over FY all over BD. And pwede natin isimplify yan. So, magkakancel yung B. So, yung phi natin or phi balance, that is also equal to 0.85 FC prime A balance all over D FY. And yung A balance nga natin, pwede natin sabihin na that is also equal to beta 1 times C balance. And yung C balance natin, meron din yung equivalent na yung C balance natin is 600D all over 600 plus FY. So, magkaroon tayo ng 0.85 FC prime beta 1 all over D times FY times closing parenthesis 600D all over 600 plus FY na ito nga yung value of C balance. And magkakancel din yung value of D kasi meron tayong numerator and denominator. So, ito yung value niya. And finally, this is another formula na kailangan natin isaulo. For phi balance, that is also equal to 0.85 FC prime beta 1 times 600 all over FY times 600 plus FY. Ngayon, pag-usapan din natin yung upper and lower steel percentages. So, meron tayong maximum reinforcement ratio, phi max. Kasi nililimit lang natin yung reinforcement natin para hindi natin maabot masyado yung maraming bakal or maabot natin yung compression controlled. Kasi nga, nililimit natin yung pag-design ng beam sa tension controlled sections. So, yung ginagamit natin for phi max, that is also equal to 0.75 times phi balance. Ay yung phi balance nga na kailangan natin isaulo, ay ito yung formula niya. Dapat saulo natin yan kasi hindi yan given sa board exam or sa mga exams. And sometimes, yung ginagamit natin in terms of area. So, yung AS max natin, that is also equal to 0.75 AS balance. Na galing din yan dito sa formula. Yung steel ratio natin is AS over BD. So, kung mag-multiply tayo ng BD sa rho or dito sa rho max and rho balance, syempre, yung makukuha natin is AS max and AS balance. So, pareho lang naman yan. So, either of the two. And for AS balance natin, that is also equal to this formula na 0.85 FC prime AB times B all over FY. And for A balance nga natin, that is also equal to beta 1 times C balance. Yung C balance, meron ding formula yan. And for beta 1, meron ding formula yan. Yung gagamitin natin, 2015. So, for the minimum reinforcement naman, dapat nililimit din natin yung reinforcement. At least, meron ganitong reinforcement. So, according to NCP 2015, Section 409.6.1.2, AS mean or the minimum reinforcement shall be greater than the value of A and B na equation. So, itong formula na yan, so meron tayong A and B, except as provided in section 409.6.1.3. So, for our statically determinate beam with a flange in tension, the value of BW shall be lesser of BF and 2BW. So, ginagamit natin yan sa mga T-beams natin or sa may mga flange beams. Pero kung rectangular lang naman, yung BW natin, automatic yung B na or the width of our beam. So, yung minimum natin, either of the two, so kung alin yung mas malaki sa dalawa, so either A or B, na merong 0.25 square root of FC prime all over Fy, BW times D. Or yung B natin, that is 1.4 over Fy times BWD. And pwede na natin gamitin ito. So kung nakarot tayo or nag-divide tayo ng BD, yung makukuha natin is raw, mean, and kung alin dito yung makuha natin mas malaki, yun dapat yung minimum reinforcement natin. So, dapat nililimit natin hanggang dito lang siya na reinforcement. Kasi hindi pwedeng masyadong malaki or hindi din pwedeng masyadong maliit. But, sabi sa 409.6.1.3, if A is provided at every section is at least 1/3 greater than A as required by analysis, sections 409.6.1.1 and 409.6.1.2 need not be satisfied. So, itong sections, ito yung na-formula na A and B. So, kahit hindi natin ito i-consider, pag yung A is provided natin is greater than or equal to 1.33, A is required. So, sabi nga, at least 1/3 greater than. Ibig sabihin, 1 and 1/3 yan. Pag nasatisfy natin itong equation, hindi natin ito i-consider na minimum reinforcement. Kasi ibig sabihin kasi ng A is provided, ito talaga yung ginamit natin na bakal. Kung number of bars, for example, yung A is required, ito talaga yung nako-compute natin. Pero yung A is provided natin, syempre, dadagdagan natin. For example, na-compute natin sa A is required is 4.3 bars. Wala naman tayong 0.3 bar. So, gagawin natin is yung A is provided natin, pwede natin gawing 6 bars or 5 bars. In provide na natin, syempre, i-compute natin yung area nun. If that is greater than or equal to 1 and 1/3 of A is required, kakalimutan natin itong formula na A and B. So, yun yung ibig sabihin ng 409.6.1.3. And for our last topic dito sa presentation, meron tayong spacing limits and concrete protection for reinforcement. So, very important to. The minimum limits were originally established to permit concrete to flow readily into spaces between bars and forms without honeycomb, and to ensure against concentration of bars on the line that may cause shear and shrinkage cracking. So, dapat yung arrangement natin of our steel bars, ganito dapat, hindi ganito. So, hindi siya naka-window. So, if we have 2 or more layers, and meron din tayong concrete cover. So, as you can see in the figure, for our beams kasi, at least dapat 40 mm yung concrete cover natin. So, galing yan sa face ng beam natin hanggang dun sa stirrups. Kasi itong bakal na nakapaikot sa mga longitudinal bars natin, this is the stirrup. Usually, yung ginagamit natin na diameter niyan is 10 mm. Na yung spacing limits natin, if we have 2 or more layers, at least yung spacing nila is greater than or equal to 25 mm. Pero kung horizontal spacing naman, meron tayong greater than or equal to the diameter of the bar or greater than or equal to 25 mm. For example, ginamit natin is 36 mm. So, dapat yung spacing natin horizontal equal din sa diameter of the bar. Pero kung less than naman sa 25 mm, at least 25 mm yung gagamitin natin. So, in addition, the nominal maximum size of coarse aggregates shall be not larger than, so meron din tayong limit dito sa aggregates natin. Ito yung ginagamit natin na graba or crushed stones. So, dapat sa tatlong kondisyon, hindi siya mas malaki doon. Dapat less than or equal to siya sa 1/5, the narrowest dimension between sides of forms, or 1/3 of the depth of the slabs. So, usually, yung depth of the slabs natin, at least 100 mm. So, 1/3 niyan, hindi dapat lalaki doon. Yung average diameter natin of our aggregate or yung stones natin. And 3/4 then of the minimum clear spacing between the individual reinforcing bars or wires. And kasi, for example, meron tayong 25 mm na horizontal spacing, dapat hindi mas malaki dyan yung diameter of our aggregates. Kasi, pag mas malaki yung aggregate natin, paano papasok doon yung aggregates natin, di ba? So, dapat mas maliit siya. So, at least 3/4 of the spacing of our steel reinforcement. So, itong tatlong kondisyon, kailangan din natin yan isaulo, especially sa board exam. So, for our NCP 2015, nakalagay itong table na 420.6.1.3.1. This is the specified concrete cover for cast-in-place, non-pre-stressed concrete members. We have concrete exposure, we have the member, reinforcement, and specified concrete cover. So, if we have cast against and permanently in contact with ground, for example, yung foundation natin or yung footing natin, at least dapat yung concrete cover natin is 75 millimeters. Pero kung beams natin, at least naman 40 millimeters. So, nakalagay yan dito. So, for beams, columns, pedestals, and tension ties, not exposed to weather or in contact with ground, yung concrete cover natin at least 40 millimeters. So, itong table guys, o mga value of concrete cover, dapat sa ulo natin yan kasi hindi yan given sa mga exams. Itong table galing to sa NCP 2015. So, that's it. Thank you very much and have a good day.